All right, let's apply our cast now reprove some identities. Okay, so we can start with this one. So we have to prove that the left hand side basically elegana the right hand side. So it's up to you whether you choose to show that the right hand side elegana the left or the left elegana the right. But I mean, usually you have to take the one that looks complicated, or we prove originally the one that looks less complicated. So I'm going to take the left hand side. Here we prove the right hand side. Okay, so left hand side I have sine to the 4 of theta minus cos to the 4 of theta. Now, in many cases, your algebra needs to be on point. I'll deal with the identities, okay? Because you'll see that, you know, it's all algebra, honestly. So, if, and I'm going to do this more often, so if you had x to the power 4 minus y to the power 4, how would you factorize this? You know, so just notice that this gives difference of two squares, something like this, and difference of two squares, so we'll solve as x squared plus y squared times x squared minus y squared. Okay, so it's more like having x squared minus y squared. This gives difference of two squares, so we solve as x plus y times, we factorize as x plus y times x minus y. Okay, so it's just that in this case your respective powers in your way give you 1, so it's just 1 here. So here give 4 equals as x squared squared, so 2 times 2 is 4 and 2 times 2 is also 4, so those two things are exactly the same, and then this will be the factorization of that. Okay, I hope that is clear enough in a way. So kilo factorize that sine to the 4 theta minus cos to the 4 theta as sine squared plus sine squared theta plus cos squared theta times sine squared theta minus cos squared theta. Now remember, sine squared theta plus cos squared theta is just 1, so this is just 1 times sine squared theta minus cos squared theta, which is just your right hand side basically. Okay, I mean, if you know the right hand side, you prove the left hand side. This will be like the easiest way. So this side, we multiply sine squared theta plus cos squared theta. So sine squared theta plus cos squared theta get 1. So this would have been more like multiplying this whole thing by 1, which is the same thing in a way. And then now we multiply out for the left hand side. Okay, this we can do. I mean, Leona can take either this side or that side. So, but I'd say the left hand side and right hand side. So if we say your left hand side, on a lay sine squared sine theta plus cos theta all squared. Now remember your exponential laws. This is not the same as x to the n plus y to the n. Okay, It's that if operation is multiplication. So if you had x times y to the n, then this would have been x to the n times y to the n. Okay, so this means I have sine theta plus cos theta times sine theta plus cos theta. Okay, so we learn only sine times sine, which is sine squared theta, plus sine times cos, that's sine cos, or only another sine cos, or multiply, there's 2, so only 2 sine theta cos theta, plus cos times cos, that's cos squared theta, and again this guy plus that guy get 1, so you end up with 1 plus 2 sine theta cos theta, which is just your right hand side. Okay, and again if you know the right hand side, we prove this. We need to change this to sine theta, sine squared theta plus cos squared theta, and then we will factorize that. You need to offer this. Okay, let's pause here, and I'll take probably 2 more in the next video. Bye for now.